Hi everyone, Sam Crawford here, Service Technician here at Intellimeter Canada, and on behalf of Intellimeter, I'd like to welcome you to our video training series. In this particular video, we are going to be demonstrating the installation process for the iMeter EM6. But before we get started, let's just take a quick moment to go over some of the components that you should have received. In your package shipped from Intellimeter, you should have received the iMeter EM6 itself, depending on what was purchased, possibly an automation module, which would be inserted right here. You should have a set of 6 CTs, and lastly, our CT programming USB dongle. This tells the meter which type of CTs are being used with it. So now that we've identified all of the components, let's just discuss some of the CT properties in relation to the iMeter EM6. The iMeter EM6 is capable of single-phase, 2-phase, and 3-phase metering for up to 2 metering points. That being said, each CT is designated for a certain meter number and phase. CTs 1, 2, and 3 are for meter 1 and are for phases A, B, and C respectively. CTs 4, 5, and 6 are for meter 2 and are for phases A, B, and C respectively. Note that there is also a load direction arrow on the CT itself. This arrow must point in the same direction as current flow. So now that we know what each CT is for, let's go ahead and install the CTs. Now, keep in mind that here we have built a mock-up panel for the sake of this demonstration video. In real-life application, you'd want to ensure that any electrical panels or equipment is totally locked off before opening or performing any work. Now, if work must be performed on the live panel, please ensure that you are wearing the appropriate protective gear, such as an arc flash suit complete with helmet and gloves. Now, moving on, we're going to first locate the circuit, load, or breaker that needs to be metered. In this case, we're going to use CTs 1, 2, and 3 to meter the main load that feeds the breaker panel. We will then use CTs 4, 5, and 6 to meter a 3-pole breaker located at circuits 1, 3, and 5. So starting at the mains, we're going to place CT1 on phase A or line 1, we're going to place CT2 on phase B or line 2, and we're going to place CT3 on phase C or line 3. Now keep in mind that the arrow on the label must point in towards the breakers as current flows in from the top of the panel down into the breakers. Now let's move on to the CTs for meter 2. Because we are installing CTs on a breaker load, a phase test is required to ensure that each CT is being installed on its correct phase. So in order to perform this test, we need to energize the panel and temporarily turn the breaker to its on position. We're going to take a multimeter and set it to check for alternating voltage. We're then going to take one of our probes and place it on phase A or line 1 main feed. Take our other probe and place it on what we believe to be phase A on the breaker. So if we have 0 volts difference, we know that this is phase A. If it was any other phase, there'd be a voltage difference of roughly 208 volts in a panel like this. So here we have 0 volt difference, so we know it's phase A. Here we have 208 volts, and here we have 208 volts. So we're going to repeat that test for phase B. Here we have 208, here we have 0 volts, and here we have 208. So we know that the middle pole is phase B. Moving on to C. Here we have 208, here we have 208, and here we have 0 volts. So we know that the bottom pole is phase C. Now that we've identified the phasing of the breaker intended to be metered, we can de-energize the panel and install our CTs. So we're going to go ahead and install CT4 on phase A, CT5 on phase B, and CT6 on phase C. Keep in mind that this time the arrow on the label must point out away from the breakers as current flows out from the breaker towards the load. Now it's time to install our reference voltage. Now the reference voltage is used to both power up the iMeter EM6 as well as provide the meter with reference to the different voltage phases. So in order to install the reference voltage, a separate 3-pole 15 amp breaker is required. We're going to want to repeat the phase test that we just covered for the breaker intended for the reference voltage, and once the phasing is identified, we can go ahead and terminate one end of the wires into the breaker and neutral block and run the 4 wires back to the meter enclosure. You're going to want to make sure to use colored wires specific to your local electrical code. As you can see, we now have our CT leads and reference voltage wires pulled through the enclosure. For the sake of this demonstration video, we have pulled them through the 1 conduit. Personally, I would suggest adding a second piece so that you can keep your CT leads and reference voltage wires separate, but for now we're just using the 1. So we're going to use a precision screwdriver to terminate the CT leads into their corresponding terminals. Starting with CT1, we use black for negative and white for positive. We want to double check the labels on the CT leads to ensure that each CT is being terminated in its correct slot. Use fork connectors for the reference voltage. Be careful not to over loosen the terminal screws as they may fall out. You can then gently pull on each wire to make sure that they're all firmly seated inside the terminals. And lastly, we are going to plug in our CT programming USB dongle. This tells the meter which type of CTs are being used with it. At this point, the iMeter EM6 should be fully installed and ready to use without the use of automation. Instructions for adding automation will be covered in a separate video, but in the meantime, let's discuss troubleshooting techniques using the live display and LEDs located at the top section of the meter. As you can see, the iMeter EM6 is now powered up and we have information showing on the display. The display cycles between kilowatt hours for meter 1 and kilowatt hours for meter 2. From a troubleshooting standpoint, we are mainly concerned with the LEDs located above the display. In order to perform proper troubleshooting, we must first put load on the circuit, breaker, or feeds that we are metering. Any load above 1 amp per phase should suffice. So the first and last red blinking LEDs marked P1 and P2 are pulse indicators. These LEDs will pulse faster depending on how much load is on the system. The two green LEDs marked M1 kWh and M2 kWh indicate which meter number is being displayed at that given time. When the M1 light is on, kilowatt hours for meter 1 are being displayed, and when the M2 light is on, kilowatt hours for meter 2 are being displayed. Lastly, the amber LEDs marked R1 and R2 are reverse indicators. If either one or both of these LEDs are blinking, it means that there is a problem with the installation of one or more of the CTs or possibly the reference voltage. If R1 light is blinking, this means that there is an issue with one or more of the CTs for meter 1. If the R2 light is blinking, it means that there is an issue with one or more of the CTs for meter 2. As you can see, here we have a blinking amber light on R1. As I just mentioned, this tells us that there's a problem with the installation of one or more of the CTs for meter 1. We're going to start by checking CT1, making sure that the CT is not installed in the reverse direction. Remember that the arrow on the CT label must point in the same direction as current flow. The blinking amber LEDs can also be a result of the CT leads being reversed at the terminals inside the meter. Make sure that the black CT lead wire is in the negative terminal and that the white CT lead wire is in the positive terminal. We're going to repeat these checks for CT2 and CT3. If everything just mentioned checks out, then there is most likely a problem with the reference voltage. We're going to repeat the phase test that was covered earlier in this video and ensure that line 1 in our reference voltage is on phase A and that CT1 is installed on phase A as well. Document your findings and if needed, make corrections accordingly. All of the same goes for line 2 for CT2 on phase B and line 3 for CT3 on phase C. So now that we've completed the installation, we've covered some troubleshooting techniques, and we powered up the meter, the iMeter EM6 is now ready to use for manual reads. As I mentioned previously, instructions for adding automation will be covered in a separate video. Once again, I'm Sam Crawford from Intellimeter. Thanks for watching, and we'll see you in the next video.